Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this integration question from the 2015 paper question 3. Let f of x equal minus x squared plus 12x minus 27. Complete table 1 below. Okay, so it's a little function. I just have written here for the older Casio calculator how to put it in if you wish to put it in using the tables function. Okay, and when you do that, sorry, I just have to put it in here now because I deleted it. Plus 12 red x minus 27. I'm starting at 3, I'm ending at 9, I'm going up in steps of 1. So I am indeed getting 0 for x is equal to 3, 5 for x is equal to 4, 8 when x is equal to 5, 9 when x is equal to 6, back down to 8, back down to 5, back down to 0. Okay, so therefore, if I was to draw this, and not that you need to, but I'm going to draw it for the next part. Okay, so it's a minus quadratic, so it's a sad face. Okay, and we can see it's going up to 5, going up to 8, going up to 9, going up to 8, going up to 5, and so on and so forth. Okay, so that's when x is 3, 4, 5, 6, 7, 8, and 9. And that height is these heights here. Okay, it's my fx column. So all I did was draw that because it's relevant for the next part, just to help explain it. So part 2 says use table 1 and the trapezoidal rule to find the approximate area of the region bounded by the graph of f and the x-axis. So there's the x-axis, there is the f function. So basically it's asking you to find the area under that curve. And it's an approximate or an estimation when it's the trapezoidal rule. Okay, so the trapezoidal rule is in your log tables, page 12, as such. And with the trapezoidal rule, what happens is all of the individual pieces under the curve are approximated to trapeziums, okay, hence the name of it. So when you're looking at a curve like this, we break it up into sections and we form trapeziums off them and so on. You keep breaking it up. So sometimes you're adding a little piece into the curve, and sometimes you're missing a piece. So here is missing, here is missing. We've added an extra piece in here. So that's why the trapeze or the trapezoidal rule is an approximation or an estimate. Okay, so there's little errors in it. So how do you do it? Well, you take your shape, whatever your shape is, you break it into sections, okay, as such. The major restriction is that the width of these sections have to be the same width, okay, which we use h for to dictate whatever this width is. And then y1 is the height that you go up. So in other words, the f of x value or the y value for each of these heights. Okay, so that's the trapezoidal rule used for calculating the area under a curve. Okay, so I'm just pasting it in here so you can see it. So that area is equal to h over 2. So if I look at my widths between each of these divisions, sorry, now I know my drawing isn't the best, but the widths are 1. So my h value is 1. Y1 is the height of the first division, and you can see it's 0. You can see it there from the table, or 0 here in the graph. So it's 0 plus yn then is the last one. So the formula doesn't know how many divisions you're going to chop this up into. This formula applies for any number of divisions. So yn is the very last one. Okay, so for us, it's a height of 0 again. And then you do twice all of the divisions in between. Okay, so again, there's your first trapezium. Okay, there's your second one. So you can see this height here of 5 in my case at the point 4 is used in this trapezium, but it's also used in this one. So all of these divisions, all of these heights in between the first and the last get used twice. So that's why these are multiplied by 2. So the way I remember it, it's h over 2, the first and the last, and twice everything in between. So there's the first, there's the last, and then I'm going to do twice everything in between. So 5 plus 8 plus 9 plus 8 plus 5. Close your bracket, put that into your calculator. No, I have to change my mode back to 1. And then so it's I'm getting 35 for that. And I would say units squared, okay? We don't know what units it's measured in, but we know area is squared. So whatever units is, it's units squared. So that's the area of this function using the trapezoidal rule. Part B then, so this often comes afterwards, and it's a very typical question to come after the trapezoidal rule. It's asking you to find the area of that function between 3 and 9 again using integration, because integration also gives you the area under a curve. So it's between 3 and 9 of what it was, our f of x minus x squared plus 12x minus 27 dx. Okay, so to integrate, you take each term and the power goes up by 1 and you divide by the new power. Okay, so 12x, the power goes up by 1, so x becomes x squared, and we divide by our new power. 27, well, the power of x goes up by 1, so we add in a power, and you could divide by 1 if you want or not, it's up to you. Okay, so we're getting the area of that curve between 3 and 9. Okay, when you're integrating here and you have got limits that you're finding the area between, you don't necessarily have to add on the plus c. Okay, now I'm going to put it in there to show you why not, but you don't have to do it because they'll end up cancelling each other out. So I'm just going to leave it there in yellow so that you see what happens. Okay, so this is what we have to get the area of. We have to integrate this between 3 and 9. So what you do is it's top minus the bottom. So we sub in 9 for all of the x's in our function. So I have minus 9 cubed over 3 plus 12 times 9 squared over 2 minus 27 times 9. Okay, and it's top minus the bottom. So now I sub in 3 for all of the x's. So minus 3 cubed over 3 plus 12 times 3 squared over 2 minus 27 times 3. Okay, and I forgot to leave room to put in my plus c. I could put plus c there, and I could put plus c there. Okay. So what ends up happening, and the reason you don't have to put in the plus c, is kind of easy to see now. I'll end up having c here, and then I go minus c. Okay, so what ends up happening is these c's then cancel each other out. Okay, so that's why when you have limits here, you tend not to see the plus c's written in at all. So put this into the calculator, see what you get. You can do it in bits, so you can do it all together. So I've got minus 9 cubed over 3 plus 12 times 9 squared minus 27 times 9. Oh yeah, I forgot to do 9 squared over 2. Okay, 1 sec now. 12 times 9 squared over 2. And I get 0 for that one. And minus, let me put this side in. So the fraction button, minus 3 cubed over 3 plus, hit the fraction button, 12 times 3 squared over 2 minus 27 times 3. And so I get minus 36 for that one. So minus 36 is 36 units squared. Okay, which one is more accurate? Integration. Okay, because integration is the process of getting the area under the curve and it's not an approximation. So using your answers above to find the percentage error in your approximation, correct to 1 decimal place. Okay, so percentage error is difference over true value. Okay, and of course multiply by 100 to convert to a percentage. So the difference is 36 minus 35. It's 36 that I got for integration, 35 for trapezoidal rule over the true value, which is the 36, multiplied by 100. So what's that? 1 over 36 multiplied by 100. Correct to 1 decimal place. I'm getting 2.77. 2.7 and it repeats. Okay, so if you hit S to D again, it expands it out, which is 2.7778, which is rounded to 1 decimal place, 2.8%. Okay, very easy to write 2.7 down for that particular one if you happen to miss the reoccurring 7 on the top.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.